Hi all, happy learning. So today we are going to discuss on how to learn programming. Is there any special way to learn programming? Let's start with how we learned a poem. It's by hearting. We used to repeatedly read the poem and by heart things, right? Literature is to touch the heart, so it's fine. But programming, is it the same way? Can we by heart it? No. It is with logic and syntax. So it is for the mind or the brain, not for the heart. And it is to think and to understand. So programming we should not by heart, or we have to think and we need to understand. So think on the logic and understand the syntax. These are the basic ways. So how we will do that? We will come into that detail. So before going to that, we have a misconcept. Like those who have learned mathematics, for them it is easy to learn programming, right? So I too had this kind of concepts. Okay, so let us see whether it is correct or not. Okay, so let us start with mathematics itself. So how do we learn mathematics? Is it the same method? In childhood, we got the advice that we need to practice, right? More than reading on mathematics. Whereas with poem, we have to read. Essays and all we have to read. Whereas with mathematics, it is practice. So obviously, the method is different. So how to learn mathematics? Let us quote one example, okay, regarding how we learned and all. So area and perimeter of a circle, shapes and all we learned in mathematics, right, in school. So this I have quoted an example of a pie, okay. So it's about a pizza. So pizza comes in a square shape, and when we open it, it's a circle. And when we take it out, people say like it's a triangle. No, it's a pie, right? Okay, let's come back to that. So I just symbolically represented that pi here. Okay, so area and perimeter of a circle. So one is pi r square, pi r square, and another one is 2 pi r, 2 pi r, right? So which one is for area, which one is for circumference? We have a confusion always, right? Pi r square is area, or is 2 pi r is area, right? Or pi r square is perimeter or circumference, or 2 pi r is circumference, right? So there is a logic to differentiate it. We all know that areas are, unit of area is meter square or centimeter square, right? Like square feet, whatever it could be. Square area is always on squares, right? So here r is radius, right? So r square means radius into radius. Radius can be 2 centimeter or 5 centimeter or 2 meter or 5 meter. So this result will be in the unit of centimeter square or meter square. So if it is pi, 3.14. 3.14 into radius. So 3.14 into radius square, that much centimeter square. So centimeter square is area. So pi r square is area. Then circumference, it is about the distance through this path around the circle, right? So that is actually circumference. So that will be in centimeter. So circumference will be in centimeter or meter. So this logic, if you relate, then we will never be confused which is circumference and which is area, right? Area is meter square, so r into r is coming over here. So this is area, and this is only r one times, radius one times, so it is circumference, right? This is one logic to understand and recollect, right? So this is all about logic. So people may be thinking, what is logic? I have not learned mathematics, so I don't have logic. It's not like that. We are having logic for each and everything we use to apply these logics in our day-to-day life. Okay, everybody has logic. Now coming to programming. So uh, we learned about mathematics, about logic, and also this is how we apply logic in mathematics, and this is how we learned mathematics. We have to learn mathematics, right, by applying logic rather than by hearting. So practice makes us these kind of idea, right? Logic is about idea. Okay, everybody has idea. Now how to learn programming. So we have uh, heard like algorithm. First, we need to devise the algorithm, the logic for the problem we need to solve. Okay, and translate that algorithm into a program using the keywords. Keywords are nothing but the vocabulary of that language, and the syntax. Syntax are nothing but grammar of that language. So first we need to have the algorithm, and then we need to translate that algorithm into a program. This is like conducting a speech, okay, like a seminar, a debate, or anything. So first of all, we need to have the idea, right? So without an idea, we cannot do anything, right? Or it will be like somebody having addressing something without having any idea, and it will be a flop, right? Everybody else will understand that he don't have an idea about the topic he is discussing. You may be thinking like even whether this person is having any idea about what he is speaking. Okay, let us conclude that thought towards the end of the session. Okay. So device algorithm is the first step in order to solve any problem, right? So algorithm, it is the step-by-step way method to solve a problem. Okay. Then translate that steps into a program in the syntax or in the vocabulary for program. So as I told, when we are addressing some people in a public speech, we need to have that idea about what I am speaking. Then it should be in the form of the uh, language. It should be in a language which the receiver can understand. So I should know the vocabulary. I should know the words in that language which I'm speaking. If I'm speaking in Hindi, I should know the words in Hindi. If I'm speaking in Malayalam, I should know the words in Malayalam. Or if I'm in Tamil, Tamil words, Kannada, like that. Or in English, English words. Okay. And syntax, the grammar to arrange those words to form a sentence, all those things by arranging those words, that vocabulary, all those things I should know. So this is all about learning a programming language. It is like learning a language. We should understand the vocabulary, we should understand the syntax, grammar. And this is about syntax part. And another thing is, as I told, logic part, the step-by-step instruction to solve a problem. That is not related to any programming language. It is related to algorithm, the logic part. Okay. So logic and syntax. Logic is the algorithm and syntax is the vocabulary and grammar of the programming language. Okay. This is what we need. This is how we can learn a program. So I have a humble request here. Please think along with me. Don't by heart. Okay. Think along with me. And if you are losing the pace, if I'm going in a speed, then please do rewatch from that. Redo the course from the part again where you lost it. Okay. And think along. If you have any doubts again, please feel free to comment and raise any query. Okay. Thanks for the cooperation. It will definitely benefit you. I can guarantee that. Okay. So how to devise an algorithm? Logic part. Okay. So if we have a problem, break the problem into manageable small sub-problems for which we can find sub-solution. This is what we do in our day-to-day life. I want to build a house or I want to purchase a car. It's a huge problem. I need a lot of money. So what I will do, I will break it into manageable sub-problems. Like I'll take a loan and break it into EMIs, which I can manage, and then I'll construct it. Okay. So this is about before having the money, I have constructed the house. Or what I will do, I will join some chit, or I will do some savings, like this sort of monthly savings. I will collect together, and then I will make a house after I have the enough fund, if I am not going for any loan. So this is how a common man does that, right? So we can do the same thing with the computer problems, or the uh, problem for which we want to find a solution with the computer also. We can use the same mechanism, break the problem into manageable components and to sub problems. Then we can find the sub solutions. Okay. So how will we find sub-solution? So simple, relate with any similar thing which we have faced or solved in the past. I'll come to that, how we will relate. Okay. Then these sub-solutions, right? Combine the sub-solution in a specific order in which we can easily solve the problem. So this is what we usually do. And we should have an attitude of making this solution, this sub-solution, scalable for any future needs, so that we will think on that, on top of it, and how we can make benefit on that thought process, we will think and we will have a scalable solution for our future needs. So I hope you are able to cope up with me. So what I told is, first step is break the huge problem into manageable sub-problem, then find the sub-solutions for those sub-problem. Then to find the sub-solution, relate with anything that we have solved in the past. Got it? For example, riding a bike. We will relate about how we learned riding a cycle, right? When we come to a car, if you know riding a scooter, clutch, gear, accelerator, all those part, we will relate with what we did in the scooter and or a bike when we come to uh, car, right? Again, when we go to heavy vehicles, again we will relate, right? That's what relation means. Okay. Then combining the sub-solution in a specific order in which we can easily solve the problem. We have uh, about that savings, right? Small savings we combine together for that big need, right? Of a house or a car or whatever need it is. Then have an attitude of making the solution scalable for any future needs. So first we will do it to purchase a cycle or to purchase a bike. Then we will be scaling that thing for any future needs, like building, purchasing a car, making a house, building a house. Okay. So all those things similar to that. Okay. So here a huge problem we have, we will break and find some solutions. We will relate and uh, solve, find solution. We will combine the sub-solution in a specific order in which we can easily solve the problem. Okay, moving on. An example for devising an algorithm. So I have a problem to print the first 10 multiples of 7, but without using 7 as an operand directly. So let me break and find the multiples of 7 first. I hope you got the problem, right? Print the first 10 multiples of 7, like so, by without using 7 as an operand. So first we need to understand the problem. It is to find the multiples like 7, 14, like that. So for that we need to break it. 1 into 7 is 7, 2 sevens are 14, 3 sevens are 21. Like that we have broken that huge problem into small stuff. But here we should not use the number 7 in order to get these things. So we cannot use this way. So we need to find a way where we can find these multiples without using the number 7. Now relate to something we have done in the past. For any number, any multiple, without using that digit, do we have any logic or do we remember any logic, any past experience? Yes. For 9, we had a past experience of a logic to prepare the multiples or multiplication table of 9 without using the number 9. So shall I reuse or relate that logic here? So what was that logic? Do you remember that? Yes, it is increased by 1 at tens place and decreased by 1 at unit place, right? So 9, then at the units place mark it as 8 and at tens place mark a 1. So it is 1 8. Then for the next one it is 8 minus 1 7 and 1 plus 1 2 2 7, right? So it is like from the previous result add 10 minus 1. So 0. From there we start. Plus 10 is 10 minus 1, that is 9. 9 plus 10 is 19 minus 1, 18. 18 plus 10 is 28 minus 1, 27. Like that. Plus 10 minus 1, we will get the multiple, right? So we are not using the digit 9 here to find the multiples of 9. We all know that, right? So we have related that problem, that sub-solution, to something we already know, right? And we combine the results, like combine all these results, we will get the solution, right? Multiples of 9. So is this logic scalable for 7? Can we extend this logic for 7? So we know plus 10 minus 1 is what did, that is equal to 9, right? Plus 10 minus 1 is 9. So for 7, what it could be? It is, yes, I know, you got it. It is plus 10 minus 3, which is equal to 7. So 0 plus 10 is 10, 10 minus 3 is 7. Then 7 plus 10 is 17 minus 3, 14. 14 plus 10 is 24, minus 3, 21. Plus 10 is 30, plus 10 is 31, minus 3 is 28. This is a bit, we are feeling it difficult. So what we can do is, we can do minus 3 first and plus 10. 21 minus 3 is, yeah, you're right. it is 18 plus 10 is 28. So anyway you can do, or so 28, then plus 10 is 38 minus 3 35, plus 10 is 45 minus 3 42, plus 10 is 52 minus 3 49. Like that we can do. So we got the logic here for solving that problem, right? So we have broken that problem into small parts. Then we have found us related that with a solution that we already know. We extended, we scaled that solution to make us find a solution. We combined all these things in order to get it. So we can use the logic here. The logic is result. That means the new result is the previous result or the current result plus 10 minus 3. So first result equal to 0. So current result equal to 0 plus 10 minus 3. That means it is 7. So we will get the result equal to 7. We will print that result. Then we will go. Now we have 7 in the result. We will again go to the previous step. 10 times we will repeat. So 7 plus 10 minus 3. That is 17 minus 3 is 14. We will store here. 14 we will print. Then again we will go. So 14 plus 10 is 24 minus 3 21. Like that we will continue and we will get the intended result. We will solve the problem by combining this logic and making this into these steps. So this is the algorithm for solving the problem. Let us coming to the algorithm now. So algorithm, what is algorithm? You all know, right? Step by step instructions. So start, define two variables, counter and result. So because 10 times we need to go. So to control that we have a counter. Then result, all in all the steps we need to find the result and go on. So first the result has to be 0. We started with the initial value of result as 0, right? So that is why I mark it as 0 here. Then let us start. Result equal to result plus 10 minus 3. 0 plus 10 minus 3 is 7. 7 we will have here. We will print it. Then counter equal to counter plus 1. We increment the counter to 2. So first digit we printed. So we need to find the second number. So if counter is less than or equal to 10. So up to 10 multiples we need to print. So go to step 5. Continue these operations from step 5 to step 8. We need to continue as long as the counter is less than or equal to 10. So every time we need to increment the counter. That is step 7 does. I hope you got it. So when we print, we will increase the counter 10 times. This will traverse or this will execute. And after that, when the counter becomes, next time it will become 2. Then result will be 14. It will print and become 2. Then result will become 14 plus 10. 24 minus 3, 21. 21 it will print. Counter will become 3. Like that, counter will increase, and when it reaches 10, it will print 70 as we know. It will increase to 10, and then it will be 10 plus 1 at that time, 11. So 11 condition false. It will not go to step 5, right? If it is less than 10, then only it will go to step 5. So at the last, it will come to stop. I hope this algorithm is understood, right? We can represent this algorithm in a flowchart. So we will come to that later. Okay, so now let us go directly to the program. Okay, actually a flowchart is nothing but a pictorial representation of this, and picture worth million words, so it is easy to understand. Okay, so that's why we use flowcharts. Okay, that's it. So let us translate this algorithm into program now, into C and C++. This is for those who have learned C and C++. Others can simply understand. We have something in green, that color, that is defining the counter and the result. Then initializing the counter variable and result. Then we have the actual operations. This is about initialization. This is about the actual operation. And then we are stopping it, right? And there is a loop control thing called a counter, right? So let us start. So in C, it is hash include stdio.h. This is to include the library that we will cover in detail in another topic. Okay, what this is. So there is a main function. So these things which are included in red or with font color red are the keywords. Okay. Then stdio.h is a library. Then we have these variables or identifiers in green. So counter, result. So we have this is the way in which in C we initialize a variable. Okay, so counter equal to 1, result equal to 0. This is the first step, or the third step, 3 and 4, right? Define counter and initialize it. So 2, 3, 4 we combine together here. So in counter equal to 1, integer counter equal to 1, result equal to 0. These things, data types and all, we will cover in detail later. Okay, so this is just an introduction about a program. So we translated that step 2, 3 and 4 into one step here in counter equal to 1, result equal to 0. Clear? Now we need to translate these four steps, 5, 6, 7 and 8. These are the repeated steps, right? Step 5 to 8 are repeated steps. So we are saying why counter less than or equal to 10. Initially it is 1, right? Counter less than or equal to 10, we need to repeat the operation result equal to result plus 10 minus 3. That is the algorithm we had, result equal to result plus 10 minus 3. So have that step here, then there is a semicolon, now full stop in C as per the syntax of C. Okay, that's a grammar, how to form a sentence. Okay, instruction. Sentence means instruction and language. Then we need to print. So for print a decimal number, we use this one, and that is the value of result. So print of slash n, that is in a new line, print the number value of result in decimal format. That is the meaning of it. Then increment counter equal to counter plus 1. So we have made this program result equal to result plus 10 minus 3, counter equal to counter plus 1, and do all these things while counter less than or equal to 10. So while counter less than or equal to 10, do this operation. That is what the C program. This is the C program for that logic. Simple, right? Now, if we learn C like this, then for C++, what is the difference? That is this blue color things, right? That's the only difference. Instead of library std.h, we use iostream.h. Main function is main, counter is 1, result equal to 0. It's the same. Int is int, keywords are same. Why? Counter less than or equal to 10, result equal to result plus 10 minus 3, that is same, but the print statement, that is different. Here it is cout result end line, counter equal to counter plus 1. So here instead of printf we use cout, instead of std.h we use iostream.h. And this is not the only difference between C and C++. As you know, C is C++. The name says there are some more. More means more keywords in C++ and its syntax. So if we add, after learning C, if we add, then we can learn C++. Got it? Scalable. Is it clear? Now I am going to the next program, that is Java and Python. So in Java also we have, here is a case issue here. Okay, I'm sorry for that. Import java.io.asterisk is the header file. Here we are including the packages. Okay, so similar to that hash include std.h, that's why I mark it in blue. Then here we have classes. These are the keywords. I'm not going to explain what class and all are. So multiples. Okay, that is our class. Then main function. Here we have other keywords also, public static void main. There are arguments also inside this. I'm not mentioning it here just for making it simple. Now int counter equal to 1, result equal to 0. This is same as that of what we had over here, right? Counter equal to 1, result equal to 0. So there are similarities. Then while counter less than or equal to 10, result equal to result plus 10 minus 3. Here again printf or cout, it is changed to system.out.println print line result counter equal to counter plus 1. So again there are a lot of similarities between C, C++ and Java, right? Now coming to Python program, here it is much more simple and is related to the algorithm that we have. So counter equal initialization, counter equal to 1 and result equal to 0, we can simply do like this. Then while counter less than or equal to 10, result equal to result plus 10 minus 3, print result counter equal to counter plus 1. Sorry, there is no need of this braces, that's typo. So this indentation helps us to identify that this is a copy paste error, I copied it from here. Okay, so here this indentation helps to identify how many statements are there in the while, whereas in Java, in C, C++, we have this set notation or the curly braces, a pair of curly braces within which we include all these things. I hope I could explain what program, what algorithm is, how logic is, how logic is translated to algorithm, algorithm is translated to program with the help of keyword, with the help of syntax. So syntax of Python, syntax of Java, syntax in C, syntax in C++, similarities, then keywords in red, so differences in blue. I could relate that. I hope it's clear. Okay, this is just an introduction. Okay, we will come to details in futures uh, videos. Okay, now just a recap of the algorithm and what we learned in this session today. So it is about breaking the program into, or the problem into sub problems, and finding the solution. Result equal to result plus 10 minus 3. Then, and print the result. Then combining them to solve the complete problem, right? That is what all this step 5. So this is what the algorithm is. Okay, so program is nothing but translating this into a syntax, and what, using the keyword, the vocabulary on the keyword and the syntax of a programming language. So in short, this is what it is. Hope it's clear. Now we mentioned about scaling that solution for future. So we discussed about a solution, right? So is it scalable for other numbers? Is it applicable only for 9 and 7? So for, let us take an example of 8. How will this be applicable for 8? So for multiples of 8, it will be minus 2 plus 10, or plus 10 minus 2. We can do with the previous result, right? So 8 plus 10 is 18, minus 2 is 16. 8 plus 10 minus 2. Previous result plus 10 minus 2. Now again, next one is previous result is 16. 16 plus 10 minus 2, 24. So this is the logic, right? So if we have applied this logic while learning multiplication table, then no need to even by heart mathematics, right? We can apply logic behind what is behind that thing, and then we can learn the multiplication table quicker, right? Again, let us scale it for higher numbers. Is it applicable only for numbers less than 10, or is it for future? Let us see that. Is this logic only applicable for numbers less than 10? How about 13 plus 10 plus 3? If I try that, you will get 0 plus 10 plus 3 is 13. 13 plus 10 plus 3 is 26. So that way, this logic is scalable for 13, and we can get the multiplication table of 13. How about 17 plus 10 plus 7? That is a bit tedious, right? But we can use plus 20 minus 3, which is simple, right? Which is easiest. So let me go with the 20 minus 3 here. So first it is 0. 0 plus 20. 20 minus 3 is 17. 17 plus 20 is 37. 37 minus 3 is 34. Good. 34 plus 20 is 54. Minus 3 is 51. 51 plus 20 is 71. 71 minus 3 is 68. 68 plus 20 is 88. 88 minus 3 is 85, and so on. You can try that. Okay, good. Now you may be interested on these things, and you can try multiples of 98 as well. The logic is 100 minus 2. So 100 minus 2, 98. 98 plus 100 is 198, minus 2 is 196. 196 plus 100 is 296, minus 2 is 294. Like that, you can get the multiples even 98. Any number. Find the logic. Multiplication of any number is in your hand, not in your heart, in your brain. Logic. That's logic. I hope I could explain what logic is, how algorithm can be formed, how a pictorial representation can be made as flowchart. That we will discuss later. But from an algorithm, how a program can be made with by knowing the syntax. Okay, good. So this logic or technique can be used while learning multiplication table 2 of even 13, 14, or any number, 17, 18, anything. So we need to learn and enhance our logical thinking from our school days. So problem is within us, that our teachers taught us the concepts, but we learned by without knowing how to learn. So we went into by hurting everything, poem, essay kind of thing. Then if we teach in future, what will be the fate of our students if you're going to teach the same way by which we learned things? So to students and to teachers, I want to tell that let us rethink on the method of learning and apply that. Okay, now Any disadvantages in this learning? Actually, I discussed this with first with my elder daughter, who is a 8th standard student now. So I explained this just to prepare for this video. I explained this to my daughter. Then she suddenly asked one question. If we want to know 13 into 7, do we need to start from the beginning, sequentially from the beginning, 13, 26, like that? I responded like this. But my response convinced her. Okay, the for response is as follows. I told her, break into small problem and combine. I told, since she's an 8th standard student, I told like 13 into 7. You break it as 13 into 5 plus 2. 5 plus 2 is 7, right? So it will be 13 into 5 plus 13 into 2. So we don't have to start from 13 into 0, from 0. We can start from 13 into 5. 13 into 5, how fast we can find it in mind? It is 5 is 10 by 2. So 13 into 10 by 2. 13 into 10 is easy, 130, right? 130 by 2 is 65, right? 60 into 2 is 120. 70 into 2 is 145. So 140. So 130 divided by 2, it will be, I'm sorry, I went wrong, I think here. So what I'm saying is 13 into 10 by 2. Okay, 12 into 10 is 120 by 2 is 60, right? So 14 into 10 is 140 by 2 is 70. So 13 comes in between. So 60 and 70, it is 65. We can calculate this in mind, right? So 13, 130 divided by 2, that is 65, 65, and the remaining into 13 plus 2. So here we can apply the same logic, 10 plus 3, 10 plus 3, like that. So 65 plus 10 plus 3, that is 75 plus 3, it's 78. 78 plus 10 is 88. 88 plus 3 is 91, right? So this is for an 8th standard student. It can be, we can break this one also, 13 also, that will be much more easy. So 10 plus 3 into 7, right? So 10 into 7 is 70, 3 into 7 is 21, 70 plus 21 is 91. That way also we can do. Okay, and some may apply some other logic also. Anything, any logic is fine, but these all are about logic, breaking the whole problem into small sub problems and getting the solution by combining the solutions together. Got it? Combining in blue, that is addition, right? Then addition that we did here, breaking into 5 and 2. Breaking is mentioned in yellow. So you can either break 7 part or the 13 part, whichever is convenient for you. I hope there is no disadvantages. When we enhance, scale our logic, then definitely our logical thinking ability will increase. So this should be the way at 8th standard we should think, right? Okay. So what is the advantages of this process? If we practice this way, our logical ability will be equal or more powerful than our memorizing ability. Or in short, we can say we will use our CPU and main memory, our processor CPU and main memory, rather than going to notebook secondary storage device. We will use our main memory. Okay, our CPU and our main memory will be used. Our logical ability will increase. So a recap on devising algorithm. How to devise algorithm. Break the problem into manageable subproblem for which we can find sub-solution. I explained it. Relate with any known or similar problems we faced or solved in the past. Then combine the sub-solution in specific order in which we can easily solve the problem. Have the attitude of making the solution scalable for any future needs. That is what. Now coming to C, learning C. Now to learn C, we have only 32 keywords. So what is the purpose? When to use what? Which keyword? That 32 keywords, that is a dictionary of C. If you understand that, and how to use it, syntax or grammar, how to use it, that is what we need to learn for learning C as a programming language. So what is the best way to learn it? Map these concepts, these keywords, and how and when to use it. Syntax, map it with something known to us. For example, when a few things I'll explain, two things, okay, and I'll wind up this video also along with that. So compiler and interpreter, you know both are translators, and what is the difference? It's simple. During the eve of this is the known thing, eve of Independence Day or Republic Day, our national leaders like president of the nation or prime minister of the nation will address through the national channel, right? It will be either in Hindi or in English. It may be a high level language for many, right? So that in South India especially, that will be translated by Doordarshan itself in by the local Doordarshan channel in local language Malayalam, so that from a high level language to low level language, all those program, that 15-minute or 10-minute or 15-minute program together, all the statements together, they will translate and telecast. That process is called compiler. Translating from a high level language to a low level language, whole thing together, that is compiler. Now, what is interpreter? Interpreter is nothing but when there is a election happening, the political leaders from Delhi will come down to South, okay, and there they can't use this compilation method. They need clap feedback for each and every statement they make. So there the process happening is interpreting. So what is interpreting? They will make one statement and that statement will be translated then and there itself. It won't be taken till the end of the speech so that another person will come and read it in local language. It's not like that. Every instruction by instruction, they need feedback. So it is translated by a translator immediately, instruction by instruction. That is called interpreter. So in computer programming also, a high level language like C or any, it has to be translated to low level language, which machine level language, by which a computer can understand it. So that process, it can be done either through a compiler, it's a software which does the translation all together, and it can also be done by an interpreter where instruction by instruction is getting translated. I hope I could relate it with something that is known to us, right? Okay, good. Now, there is another thing. This is for the people who have learned programming. Okay, in C, C++, Java, and all, we have if else if ladder. Okay, so its syntax is like this: if condition, then statements; else if condition, two statements. So how this will work? People may have a lot of misconceptions. So I have to. This is an example, a real life example with which we can clear it. Okay, this is kind of a ladder, and each blue color can be steps. Okay, so here it can be as it is named, so ladder. Why that name? So in it, the working of this construct is similar to that of the working principle of a ladder. Okay, so how or when we use a ladder in order to take something from a height which is not reachable for us. Okay, and how will we use a ladder? First, we will go to the first step. We'll check whether the condition is met. Are we able to reach that? Right? If we are able to reach that, what we will do? We will take it from the first step and we will come out of the ladder. Or if our condition is satisfied, will we go to the next step? Anyway, I have stepped the ladder, so let me go through all the steps. Like that, do we do? No, it's not required, right? If the purpose is met in first condition, then we will come out of the ladder after doing that. If it is not met, then only we will go to the second step and see whether the condition is met. We are able to take it, right? If not, then only we will go to step 3. Like that, there could be n steps. We will do only if n minus 1 step is not satisfied, where the condition is not satisfied, then only we will go to the next steps. And if all the steps are exhausted, what will we do? For example, we need to pluck a coconut from a coconut tree, and from the last step also it is not reachable. What will the person do? He will climb on the tree itself, right? That way, here also, if condition 1 is met, the statements corresponding to that condition 1 will be executed and we will come out of the structure. If it is not met, then only the second condition will be, second step will be checked and statements will be executed if it true. If not, next step. Like that, there could be n conditions, n condition. After checking all these conditions, if none of the conditions are met, then as I told, climbing the tree is the only way. There is an else block here, that else block will be executed. So I hope with this example we can relate the working principle of else if ladder. If it's not clear to you, please revisit this particular part, this particular slide, and listen it again. It will be clear. Okay. So we explained about logical thinking and by hearting. So I think I addressed the major complaints of students while learning programming, that is logic and syntax. Logic is what? Thinking in C. Syntax is what? Let us see. Use it, practice it. Then definitely you will get it. So these are the two books which mainly people refer. Okay. So I have quoted that. Think and practice. That's the only way to learn programming. Okay. So I congratulate those who have already identified this as an issue, those who have already identified. So it is easy for them to overcome if they know the problem. Okay. Now, how to overcome this? If you feel these sessions by me will help, Please like, subscribe, and comment for further updates. Thank you. Have a good day. Bye. So, about me, you can read it. Thank you. Thanks a lot. Bye.